Hello everyone, this is Mr. Baraboo. I'm going to be recording a quick video going over one of the questions for our upcoming Unit 2 checkpoint. What we need to do is be able to sketch or, well, ideally graph. I don't want to sketch this. I want to actually make a real graph. Let's graph a line of each equation. I'm going to do this one right here just because it looks a little, it's got a little bit more going on, so that feels like fun. Things that I'm going to look out for is just looking at this, I'm going to notice that there's a negative in there. Okay, you should always look at the question, try and figure out, okay, where might I make a mistake? So I've got a negative in there. Okay, so let's keep that in mind. General form, which this is also often called intercept form. And the reason why that is because you can find the intercepts with it pretty easily. This is how we do it. We have to know a little bit about the intercepts. I know that the x-intercept is always going to be along the x-axis, and the y-intercept is always going to be along the y-axis. What that means is that the x-intercept is always going to have a 0 for the y, right? Because if it's along here, y is always going to be 0, okay? And for the y-intercept, the same is true except for with x. Because if it's along the y-axis, then x is going to be 0. All right, so what we could do is just figure out what this is going to be when y is 0, and that'll give us the x-intercept, and when x is 0, that'll give us the y-intercept. So let's start this off with the x-intercept one. So we know y is 0. So I'm going to say 4x plus 5 times 0 equals negative 8. I'm going to notice that we are multiplying something by 0. When you multiply something by 0, it doesn't go away. It becomes 0. So 5 times 0 is 0. But then we're adding 0, and that doesn't change the value of it. We really don't have to think about this much. It's kind of gone. And so what people will normally do with these is actually like cover up the thing itself. So if I want to find the x-intercept, I would cover up y and then solve for x, which is effectively what we're doing here. So let's solve for x. I'm going to divide both sides by 4 to get x alone. And remember, we got to do everything the same on both sides. 4 divided by 4 cancels out. It doesn't really cancel out. It turns into 1, and 1 times anything is itself. So it's just got x. And over here, we've got negative 8 over 4. If you're not sure what that is, you should know what that is. But if you're not sure what that is, there's no shame in using a calculator. Okay? But that ends up being negative 2. So when y is 0, x is negative 2. Well, what does that point look like? When y is 0, x is negative 2. So that coordinate would be right there. All right, let's figure out the y one. And for this one, I'm going to go a little faster because I can actually use that trick we just discussed with this. I'm going to cover up the x to find the y-intercept. And what we're going to see is that we need to divide both sides by 5. So what we're really going to do is be dividing negative 8 by 5. Now this one I am going to use a calculator for because it's best practice to when you're trying to be precise. So negative 8 divided by 5 gives me negative 1.6. So my y-intercept is going to be at negative 1.6. All right, let's figure out where that would be. X is 0 and y is negative 1.6. So it's going to be a little in between where 1 and 2 would be, or negative 1 and negative 2 would be. So that's like right there-ish. And since I have 2 points, and I know general form is linear, hence the word right there, we can connect these into a line. I'm going to use a little straight edge to do that. And ta-da. Now, I like to go way beyond my graph just to show that this does go on forever. You should put arrows on the end because it goes on forever. And then we could actually test this by plugging in values to see if they would work. As it is, we have officially sketched our graph. If you have any questions on this, either find me in the math hall or ask your teacher.